Hello, classmates. In this class, we will study Chapter 1, the composition and structure of printing paper. In this section, we will learn about the composition and structure of printing paper together. Section 1, Composition of paper. Paper is a porous sheet-like material. It is composed of plant fibers that are interwoven with each other, according to its application fields and performance requirements. Appropriate auxiliary substances such as sizing agents, colorants, and fillers are added. The main material of paper, plant fibers. The basic structure of paper is a uniform thickness substance formed by interwoven fibers. And fibers are the framework of paper. Plant fibers used in papermaking include plant-based, mineral-based, synthetic, resin-based, and metal-based types, etc. Regardless of the form of plant fibers, their main chemical components are cellulose, hemicellulose, and lignin. Cellulose and hemicellulose are both carbohydrates, while lignin is an aromatic compound. Cellulose is the main component of plant fibers. Pure cellulose is colorless, insoluble in water, and flammable. It has a density of 1.55 grams per cubic centimeter, and its molecular formula is C6H10O5, whole to the N. It is a linear polymer compound, a polymer without side chains, that can melt when heated and dissolve in appropriate solvents. The figure shows the structure of cellulose. Due to different types of cellulose, the degree of polymerization N, the average number of repeating units in the macromolecular chain of the polymer, varies, and the length of the fibers also varies. Generally, the larger the degree of polymerization, the longer the fiber, and the higher the strength and better the quality of the paper made. For example, in cotton, N is between 5,000 and 6,000, in wood, N is between 2,000 and 2,500. In reed, N is about 1,000, and in straw, N is about 600 to 1,000. Cotton has the highest cellulose content, approximately 70% to 90%. The cellulose content in coniferous wood and broad-leaved wood is similar, generally 43% to 53%. And the content in grass-based raw materials is the lowest, about 35% to 48%. Hemicellulose is the part of cellulose raw materials that dissolves after being immersed in a 17.5% to 18% sodium hydroxide solution at 20 Celsius degree for 45 minutes. It contains a large number of hydroxyl groups, so its water absorption and swelling ability is greater than that of cellulose. To a large extent, the ease of fiber water absorption and swelling depends on the amount of hemicellulose it contains. According to the different properties of goods, plastics can be processed into plastic bags, plastic bottles, plastic boxes, etc. to better protect and display goods. Plastics can be transparent, translucent, or completely opaque. Lignin is a natural polymer compound with a three-dimensional structure, accounting for about 20% to 30% of plant fibers. Its structure is different from that of cellulose and hemicellulose. It has a phenol-propane structural unit, connected by ether bonds and carbon-carbon bonds, forming a three-dimensional network structure, which is a non-linear polymer. Lignin exists in plants, playing a role in bonding fibers and enhancing the strength of plant tissues. The following are the three main structural diagrams of lignin, namely guaiacyl, syringil, and p-hydroxyphenyl. Let's think about a question. Why is lignin removed in the papermaking process? This is mainly because lignin is a hydrophobic substance that is not easy to absorb water and swell. Therefore, when the lignin content in the fiber is high, the fiber will be hard and brittle, which is not convenient for the interweaving of fibers. So, lignin needs to be removed to a certain extent during the pulping process. In addition, when lignin remains in the finished paper, it will generate chromophories when exposed to light and sunlight, causing the paper to turn yellow. This is the main reason why newsprint is prone to yellowing, brittleness, and poor durability. In addition, paper also contains some other minor components, mainly including pectin, various extractives, and minerals. Among them, the pectin content is less than 1%. Extractives include fructose, tannin, starch, fat, resin, and wax. Minerals are the substances remaining after the raw materials are burned, called ash. The second component of paper, fillers. Concept: finely divided mineral particles with strong dispersibility are added to fill the pores in the network structure formed by the interweaving of fibers during paper making. Function: it improves the physical properties of paper, making the paper surface uniform and smooth, and enhancing the smoothness, opacity, whiteness, water resistance, etc. of the paper. It also improves the ink absorption performance of the paper and keeps its size and specification relatively stable. Filling: the process of adding fillers during the paper making process. Commonly used fillers include talcum powder, china clay, precipitated calcium carbonate, titanium dioxide, titanium white, barium sulfate, etc. It should be noted that the amount of filling should be appropriate, generally accounting for about 20% of the paper. The third component of paper, sizing agents. In order to improve the water resistance of paper and reduce the capillary action of plant fibers in paper, hydrophobic substances that can fill the gaps between fibers or form a sizing film on the paper surface are added. Sizing: the process of adding certain hydrophobic substances to paper. It can be divided into internal sizing and external sizing. Function of sizing: it mainly improves the water resistance of paper and can also improve the gloss, smoothness, surface strength, mechanical strength, and stiffness of the paper. Commonly used sizing agents include oxidized starch, polyvinyl alcohol, carboxymethyl cellulose, animal glue, synthetic resin, aluminum sulfate, rosin size, etc. The fourth component of paper, colorants. Colorants are general terms for materials used to increase the whiteness of paper or change the color of paper. When producing colored paper, dyeing is required, and the commonly used methods are coating and dipping. When producing white paper, color adjustment and whitening are also often needed. Unbleached pulp contains lignin or other chromophories, showing a dull light yellow, light green, or gray-white color. After color adjustment, the miscellaneous colors can be eliminated, the hue can be harmonized, the paper becomes pure white, and the color of the same batch of products can be kept consistent. Generally, the methods of filling, coating, and dipping are used. Well, after introducing the composition of paper, let's introduce the structure of paper. Paper is a non-homogeneous material formed by the complex entanglement and interweaving of macroscopic fibers. Its structural characteristics are as follows. 1. It has multiple components. 2. The distribution of each component in the paper is uneven. 3. Most papers have anisotropy on both sides, front and back. 4. Paper has a complex porous structure. Porosity: it refers to the ratio of the pore volume of paper to the total volume of paper. The average pore radius along the longitudinal direction of the paper sheet is the largest, and the average pore radius along the thickness direction is the smallest. For printing paper, it is 0.02 to 0.2 micrometers. The evenness of paper: it represents the uniformity of the paper structure. It is usually used to describe the relatively uniform distribution of fibers and other solid substances in the paper. The quality of the paper's evenness indicates whether the paper has the same structure, composition, and properties. The evenness of paper is closely related to the dispersion of fibers in the pulp suspension. If the fibers in the pulp suspension are well dispersed, and the degree of fiber flocculation is relatively low during the pulp flow feeding and paper forming process, the formed paper will have better evenness. The grain of paper. It refers to the arrangement direction of most fibers in the paper. The direction along the fibers is the longitudinal direction, and the direction perpendicular to the fibers is the transverse direction. Paper with the fiber arrangement direction parallel to the long side of the paper is longitudinal paper. Paper with the fiber arrangement direction parallel to the short side of the paper is transverse paper. The reason for the formation of the grain of paper is that during paper making, due to the translation and vibration of the copper mesh, most fibers are oriented in one direction, thus forming the longitudinal and transverse directions. What are the effects of the longitudinal and transverse directions of fibers in paper on the properties of paper in various directions? The differences in tensile strength, breaking length, tear strength, folding endurance, and the dimensional change of paper after water absorption in the longitudinal and transverse directions of the paper affect the quality of printed matter. Generally, the folding endurance of paper in the longitudinal direction is greater than that in the transverse direction. The tensile strength in the longitudinal direction is greater than that in the transverse direction. The amount of transverse deformation of fibers is larger than that of longitudinal deformation. There are usually the following simple methods to judge the longitudinal and transverse directions of fibers in paper. 1. Tearing, paper method. 2. Strip, bending method. 3. Paper, sheet curling method, soaking method. 4. Mechanical, property identification method, tensile strength, folding endurance, etc. 5. Back, lighting method. The front and back sides of paper. When paper is made by a Fourdrinier paper machine or a Cilinter paper machine, the side against the forming wire section is called the back side, also known as the wire side, while the other side against the felt press section, drying section, is called the front side, also known as the felt side. For a twin wire paper machine, both sides are wire sides, and there is basically no problem of front and back sides. The difference between the front and back sides of paper is caused by the different proportional distribution of long fibers, fine fibers, fillers, sizing agent particles, etc. on the two sides of the paper web, and the different imprints of the wire and the felt on the paper surface. On the back side of the paper, not only is the proportion of coarse fibers larger than that on the front side, but also the wire mark, formed by the paper-making wire on the wire side, is much more obvious than the felt mark on the front side. Okay, classmates, that's all for this class. See you in the next class.